Hi everyone. Today in this video, we are talking about a term called magnetic induction. So let me start by talking about a term called magnetic field. So around every pole, maybe a north pole or a south pole, there is certain space up to where maybe some imaginary space. It can influence the other poles. Mean to say, if this is a north pole, if I get one more north pole within that space, that north pole experience a repulsion. If I get another south pole, that will experience a attraction because of this north pole. That's the space around a pole where its influence can be felt, can be experienced all over here. I mean to say, if I have a pole beyond there, that means there is a north pole here. On this north pole is not going to show any influence, no effect. Mean to say, every pole has a space around it up to where it can influence the other poles, maybe attracting or repelling. That space around that pole is called magnetic field. Now, within the magnetic field, say let the first pole is having a pole strength M1, there is another pole of pole strength M2. Between them, there is a known distance D. If this is also a north pole, between similar poles, there is a repulsion. How much is that repulsion is? We have an inverse square law. Mu naught by 4 pi m1 m2 by r square, where mu naught is the permeability of the free space, which tells you how conductive the free space is in passing magnetic field through it. Now, let's talk about this term, magnetic induction. Let's come to the term magnetic induction. Yes, magnetic induction. It could be also called something like magnetic field strength, sometimes simply magnetic strength itself. Right. Now, imagine a pole, say a north pole of pole strength M. Around that pole, up to somewhere, there is a field. Within that field, if I keep another north pole, but of pole strength 1 unit, 1 ampere meter, SI unit is ampere meter. Between them, there is definitely some distance D. Because this is a north pole, this is a north pole, on the kept north pole there is a force of repulsion. So the unit north pole kept within the magnetic field of another pole experience a force. How much is that force is? The same, mu naught by 4 pi. M1 is M, but M2 is 1 because what I have placed here is a unit north pole by d square. This force is called magnetic field or magnetic field strength or magnetic induction or magnetic intensity sometimes. We'll say come talk about the names little later. We have to look at the unit. Based on the unit, we have to decide what's the physical quantity that you are talking about it. Don't worry about the names because people use different names under different say, circumstances. So what is magnetic induction or a magnetic field strength is the we can define it as the force experienced by a unit north pole when it is placed in the magnetic field of a pole. That's it. That is that simple. So magnetic induction is the force experienced by a unit north pole when placed in a magnetic field. What if we have not kept m equal to 1? If you kept m equal to 2, here you have kept m equal to 1. If you have kept 2, I'll be getting a 2 here. If I have kept a pole of strength m, another m, in this field, that is in the place of unit north pole, Everything in this equation will be the same, but only in the place of this 1, I'll be getting a m. So in the place of this b into 1, I'll get b into m. So what happens then? In that case, F becomes mb, where B is the magnetic intensity or magnetic field strength. B can be written like F by M, just for a formula sake. But it is a force experienced by a unit north pole when placed in a magnetic field. So what could be its SI unit? It's SI unit I'm talking about. Force is measured in Newton. Pole strength is measured in ampere meter. So total SI unit is Newton ampere meter. In the name of a great scientist, it's being named as Tesla. We call it like a Tesla. So we can also write what its dimensional formula is. Dimensional formula. B, magnetic field strength or magnetic intensity. It is force F by B. It is force is MA, that is MLT power minus 2. F by M, F by M. M is the pole strength, that is ampere meter. Ampere is shown with an I. Meter is shown with L. So L and L can be cancelled. So M, L power 0, T power minus 2, I power minus 1. I can write this because I, ampere, is being treated as a fundamental quantity in SI units, SI system of units. So I repeat to tell you again that magnetic field strength is, if I have to write, I can write it, magnetic field strength or magnetic intensity or magnetic induction is the force experienced by unit north pole when placed in a magnetic field of another pole, when placed in a field of another pole. That's how we talk about magnetic field strength or magnetic induction. Further, we will talk about this magnetic field strength so many times in the coming videos. Thank you for watching.